Unit 1, Section 4. Example 1. Given the universal set 1, 2, 3, 4, 5, 6, 7, 8, and A 1, 2, 3, 4, determine A complement and represent it in a Venn diagram. Let's remember that A complement is everything that is not in A, written as a set. So since A is 1, 2, 3, 4, we look at this universal set and say, what's left? And it is the set 5, 6, 7, and 8. Example 2. Given A is a set containing dog, cat, deer, and mouse, and B is the set containing bear, deer, and mouse, find A intersect B and represent it in a Venn diagram. A intersect B is the set of elements in both A and B. It's an overlap. If you think of it as a road, where two roads cross is called an intersection. It's where they overlap. So A intersect B is going to be all the animals that are in both sets. Dog is not in both sets, cat is not, but deer and mouse is, bear is not. So it's going to be the set containing deer and mouse. Example 3. Given the sets, universal set numbers 1 through 10, the natural numbers 1 through 10, A is 1, 2, 4, and 8, and B is 1, 3, 5, 7, and 9, and C is the empty set. Determine A intersect B, A intersects C, A complement intersect B, and the complement of the entire intersection of A and B. So if we start with A intersect B is where A and B overlap. So if we look at these two sets, we're looking at 1, 2, 4, 8 intersect 1, 3, 5, 7, and 9. You don't have to write them out like I do, but I like to do that. So the only thing they have in common is the 1, the number 1. So that's the intersection of A and B. B, A intersects C. Now we're looking at 1, 2, 4, 8 intersect the empty set. So the intersection is always a set, but in this case, this set has no elements, so they have no overlap. So the empty set is the intersection. C, A complement intersects C. So what's the complement of A? It's the opposite of 1, 2, 4, and 8. So it's going to be 3, 5, 6, 7, 9, and 10. And we're intersecting that. Oh, it's A complement intersect B. Thought that sounded wrong. So A complement intersect B. So we're intersecting 3, 5, 6, 7, 9, and 10, the opposite of A, with B, 1, 3, 5, 7, and 9. Here's where they intersect. We have 3 in both, 5 in both, 7 in both, and 9 in both. I like to check them off so I don't miss any. So we have the set 3, 5, 7, and 9. And finally, D gives us a big parentheses with A intersect B inside and a complement on the outside. So that means first we find A intersect B, which we did up in A. We found it was the number 1. Or just looking at A and B here, we see the only thing they have in common is the number 1. So we want the complement of that set. So it's going to be the universal set except for 1. So 2, 3, 4, all the way up to 10. Example 4 gives us A equals dog, cat, deer, mouse, and B equals bear, deer, mouse, and asks us to find A union B. A union B is the set of all elements found either in A or B or both. So it's like the big party, everybody's invited. So we have A, dog, cat, deer, and mouse. And then we look at B and see what we left out. We left out bear. Deer, already have it. Mouse, already have it. So we're done. So that's A union B. Example 5, given the universal set 1 through 10, A is 1, 2, 4, 8, and B is 1, 3, 5, 7, 9. Looks familiar. Determine A union B, B, A complement union B, and the complement of A union B. So doing the complement last. So let's look at A. Asks us for A union B. So we want everything that's in either set. So we have 1, we have 2. I'm going to go ahead and number them right away so I don't have to put them back in order. So 3 we got, 4 we got, 5. We don't have 6, but we do have 7, 8, and 9. B. We're asked for A complement union B. So first we need to figure out what is A complement. So A complement is everything that's not in A. So let me erase that. Get those lines off of there. That's a little better. So A is 1, 2, 4, and 8. So we're going to look for the opposite of 1, 2, 4, and 8. So not 1, not 2, but yes, 3. Not 4, but yes, 5, 6, 7. Not 8, but yes, 9 and 10. So that's A complement, and we want to union that with B. So we're going to also add these numbers in if they're not already there. So A complement union B will include 1 because 1 is in B, but not 2. Yes, 3. Not 4 because it's not in here and it's not in B. Yes, 5, 6, 7 because it's right there. Not 8. Yes, 9. Yes, 10. And C asks for A union B complement. We found A union B up here. It was 1, 2, 3, 4, 5, 7, 8, 9. So we want the complement of that. So we don't want 1 or 2 or 3 or 4 or 5. We do want 6. We don't want 7, 8, or 9, but we do want 10. Okay, a recent survey of the Tuesday morning visitors to the New Bedford Whaling Museum showed that 24 spoke English, 14 spoke Portuguese, and 12 spoke both English and Portuguese. How many spoke either English or Portuguese? So we're looking at a Venn diagram. So when we want to know who spoke English or Portuguese, and we're given both English and Portuguese, we're going to use the rule, the number in the union of A and B is equal to the number in A plus the number in B minus the number in the intersection of A and B. Now we're going to be talking about English and Portuguese, so I'm going to change that to be E for people who speak English, union, and P for people who speak Portuguese. Then it's easier. So number in E plus the number in P minus the number in E intersect P. So E union P are the people that speak either English or Portuguese. The number in E speak English. The number in P speak Portuguese. E intersect P are the ones that speak both English and Portuguese. So the number that speak English or Portuguese, this is what we're looking for, the or. So we'll leave that blank for a minute. The number that speak English is 24. The number that speak Portuguese is 14. And the number that speak both is 12. So we have 24 plus 14 minus 12. This gives us 38 minus 12, which is 26. So the number that speak either one is 26. Example 7. Given A is the set apple, ball, cat, and B is the set dog, ear, ball, determine A minus B and A times B, A cross B. So A minus B is everything in A, but not in B. It's like you're subtracting away anything in B. So if we look at, we have apple, ball, and cat. Dog is not in there, so we don't have to worry about it. Ear is not in there, but ball is in there, so we're going to take ball out. So A minus B is just apple and cat. Now A cross B, or the Cartesian product of A and B, is a set of all elements that have something in A and something in B. So we want to do all those possible elements. So we're going to start systematically with apple. So if the first element is apple, we have 3 choices for the second. We have dog, we have apple and ear, and we have apple and ball. So those 3 pairs are the apple part. Now below that, we're going to do the same thing with ball. So we have ball, dog, ball, ear, and ball, ball. Okay. It's okay that it's the same one. And then we're going to do the same thing for cat. So we have cat, dog, cat, ear, and cat, ball. And close the set. It's fine to write it as 3 lines like this to make you more organized. So again, we're taking the first element and using it every time we need to cover all of the second set. We take the next element and cover the second set. And we take the third element and cover the second set.